disclaimer just so you're. There we go. Hello, everyone. Welcome to all those in grade 5, teaching grade 5 science with the new science curriculum. My name is Ted Zeroni. I am a consultant with the Edmonton Regional Learning Consortia, and Chris Zarski is joining us, but not right away. She will be here. She's a little bit late. She's working with the Central Alberta Regional Consortium. You'll know that there's often reference to something called the ARPDC. Maybe we should just explain that right now, and you can see the logo there. The Alberta Regional Professional Development Consortia, or ARPDC, is an umbrella organization that encompasses all the different regional consortia, such as Edmonton Regional Learning Consortia and CARC, or the Central Alberta Regional Consortia. So just so you know that we're all kind of under the same umbrella, but regionally we spend time with schools and working close with teachers within our own regions. So all the stuff that we're posting for science is going to show up on the ARPDC website, and Chris will give you a tour of that at the end of our presentation. To begin today, as we always do, I would just like to begin with our acknowledgement of land and people. And as we often do, if you've been with us, we begin with a video of some sort. We thought the video called The Honorable Harvest by Robin Kimmerer would be a really appropriate one for October. It is a time of harvest, and perhaps makes a lot of sense to view that at this time. Many of you know Robin Kimmerer is the author of Braiding Sweetgrass, and this is an excerpt of some of her teachings in this short video. So I'd like to play it for you now.
If I could choose just a single element of the traditional teachings that we're called to pick up, it would be the teachings of the honorable harvest, which were taught us by the plants, who give us everything that we need. It's a covenant of reciprocity between humans and the living world, a very sophisticated ethical protocol. One of the first steps of the honorable harvest is to understand that the lives that we are taking are the lives of generous beings, of sovereign beings. And in order to accept their gift, we owe them at least our attention. To care for them, we must know what they need. And at the very minimum, we should know their names. And yet, the average American redwoods. The protocols for the honorable harvest are not really written down, but if they were, it would look something like this. When you get to the woods, you don't just start grabbing everything in sight. We're taught never to take the first plant that you see, and that means you'll never take the last. This is a prescription with inherent conservation value. And then if we encounter another plant, we ask permission. I've always been taught to address that plant, to introduce myself and tell it what it is that I have come for. If you're going to take a life, you have to be personally accountable for it. I know there are places where if you talk to a plant, they think you are crazy, but in our way, it's just good manners. If you're going to ask, you have to listen for the answer. You can listen in different ways, pragmatically, intuitively. Look around, see whether those plants have enough to share. And if the answer is no, you go home. For we remember that they don't belong to us. And taking without permission is also known as stealing. And the Honorable Harvest counsels that we also take in such a way that does the least harm and in a way that benefits the growth of the plant. Use everything that you take. It's disrespectful of the life that's given to waste it. The next tenet of the honorable harvest is to share it with others, human and non. The earth has shared generously with us, so we have to model that behavior in return. And a culture of sharing, we know, is a culture of resilience. Plant gatherers often leave a spiritual gift behind, but it can also be a material gift. Weeding, caretaking, spreading seeds, helping those plants to flourish. We give songs, we give ceremony, we give our respect, we give fertilizer. Every breath that you take is a breath that was made for you by plants. On the water that you drink, whether you're in an urban setting, whether you're on a remote mountaintop, we still are recipients of those gifts. And if we take the time to be grateful, that brings us into that state
of humility, of understanding that we are not at the top of a biological hierarchy, that in fact we are the younger brothers of creation.
This video is quite fitting actually for this grade 5 unit on our Earth systems. As we know, there's a large portion of this curriculum, of this organizing idea dedicated to agriculture and sustainable agricultural practices, as well as references to First Nations and Indigenous harvest practices. And so we can learn from this video, of course, as we and keep the teachings of this in mind as we look through this curriculum. Those of you who have been with us over the pilot sessions and at the beginning of last spring, you'll know that Chris and I present the organizing ideas in a certain way. Our first sessions with the new implementation version of the curriculum began last spring. We have living systems K2 or grades 1 to 6 completed. Matter K-6 is completed as well. And those you'll find on the ARPD site. What you'll find when you get to that site is a video, the recording of our session, and a copy of the slide deck that accompanies that session. So if you haven't seen those and don't have the resources from those recordings, by all means, please go to the ARPD site and look for that. Also included is something called a session 1. It doesn't refer to any particular organizing idea, but it gives you the broad idea and a framework of how Chris and I are unpacking the curriculum, looking through the 3 phases of learning, and gives that more of a foundational look at the curriculum. And we urge you to look at that one, because we'll be covering some of those ideas in this particular session. We won't be going as much detail as we have in the past. So we're assuming that there are some things that you're already understanding. And if you don't, you can by all means look back. So we are going to still take a look at the idea of concept, skills, and procedures and understandings, and how that's related to the whole notion of transfer for learning. We won't spend as much time doing that in the past, but we will look at it as we have in past sessions, excuse me, but we will look at it through a different lens a little bit than we have in past sessions. Then, of course, we'll be looking at some teaching approaches and a lot of different activities and resources that Chris is going to share with you. And what we'd like you to keep in mind is when you look at those, to keep in mind the big picture that we're going to be presenting at the start here. It just gives, I think, us more agency when we have the big picture and know how we're doing is going to impact learning in a broad spectrum as well as on an individual student's situation. So when we take a look at the spiraling curriculum, we do refer to the spiraling curriculum because, as we know, we moved away from topics in our old curriculum to more of a curriculum that is connected from grade to grade and within each organizing idea. So instead of separated, it's very spirally and connected. And I would just like to show you a couple of graphics to explain what we mean about a spiraling curriculum and how the concepts in the curriculum are integrated and build with one another. I'm going to start at grade 2 just because there's a really strong connection between grade 2 and grade 4. And grade 2 students really focus on the Earth's components. And those components are water, land, plants, animals, and air. And we'll see by the time we get to grade 4, the same organization is there, and how those components of water, land, plants, animals, and air sustain life. When we get to the focus in grade 2 is on the water forms and land forms. So water bodies, rivers, lakes, and so on, and land forms like mountains, valleys, volcanoes, and so on. So the emphasis on that. When we get to grade 3, pretty much the similar idea, except the emphasis is on change. So how does the Earth's surface change? What causes change? And how do we relate to change? How does the change on the Earth's surface affect us? And how do we affect the Earth's surface? Of course, there's more to it than that. I'm just giving you some of the big ideas of how this is all connected. By the time we get to grade 4, the structure doesn't change much. What happens is we take a look at the same components, but we give them bigger names. Instead of land, for example, we're using the word lithosphere, and then hydrosphere, biosphere, and atmosphere. Now we not only look at those spheres in terms of what they're composed of. For example, we know that the landforms are part of the lithosphere. But grade 4, there's now beginning to be an emphasis on the interaction between those things. How do those things interact to sustain life? We know they change. We learned that in grade 3, and now how do they interact? Now in grade 5, there's really not much. There's a lot to it, and I'll give you a separate nap later. But at the end of the day, if you've looked at it at this learning outcome, we know that the big idea is really connected and to the idea of atmosphere. And we're developing concepts related to the atmosphere much more, and specifically climate and weather. And we do know then when we're talking about interactions, and we're talking about how that interacts within all our daily living and all human activities, but specifically how that interacts with our agricultural practices. By the time we get to grade 6, not much big change again when it comes to Earth systems. It really, you could see that orange arrow go up to change, and we're talking about climate change by the time of grade 6, and that's the emphasis. I'm just going to go a little bit further here, because you know at the top there's that word systems, and systems are basically components that work together for one goal or one final end. And we can see how the Earth systems are combining together to sustain life. Grade 5 living systems also looks at systems. You can see that they're the biological systems. And when you can see how other organizing ideas are connected to this, you get a bigger idea of how this is all put together and how things do relate to one another. So we have different components of the biological system, which also helps sustain life. And of course, by the time we get to grade 6, and we're talking about living systems again, we're talking about ecosystems. And we can see how that's so clearly related to these components here we learned in grade 4. And there's another system that we look at in grade 6, space, and that's the solar system. Now, at the bottom, you'll see that there's the organizing idea. And really, the organizing idea for Earth is that it focuses on the whole idea that there's all these systems are working together, and they're all interacting to sustain life and balance and harmony in our world. So I thought this graphic might be important to see, just to see that each organizing idea, again, is not in isolation. They're all connected in some way to each other. Specifically for grade 5, this organizing idea is organized this way. I see I have the wrong one up there. It's not totally completed. Looks complicated. There is a lot of stuff really in this unit, a lot of facts and a lot of knowledge and facts, but it's organized in a way that I think is quite manageable. So what we're looking at here again is the focus is on the atmosphere, specifically climate and weather. We know that weather is more of a short-term thing. We could see the orange line come off of atmosphere, or the sort of dark orange come off of atmosphere. And we could take a look at how atmospheres or weather is really about the conditions on a short term. And we have tools, which is the gray items here, used to measure certain things or certain conditions in the atmosphere, such as those listed here. We know that climate is different in terms it's a long-term pattern, and each climate has its own characteristics, which are also these things embedded in the middle here. This organizing idea also takes a look at weather prediction and how that happens, and how traditional knowledge and more scientific methods help in predicting the weather. When it comes to climate, we not only look at the patterns and the characteristics of climate, we also look at factors of the yellow bunch that affect climate. So geographic location and landforms and altitude and proximity to water are all factors that shape or affect a climate and make it what it is. And of course, know that climate affects activities, whether it be animals or human. And we see a list of possible activities listed here. And this isn't finished off here. My apologies, it will be, that we have the different agricultural practices. And finally, we do take a look at some of the climate zones as well. So a lot of stuff in there, but we think it's, as we go through here, hopefully you get some ideas that will help you unpack it and be able to get some stuff here to deliver this to your class. Just for that whole notion of concepts and how they're all related, that graphic I showed you, that as the progressions from grade through is there for living systems. There's also more of a lineal verbal way to look at it. There's this document that you'll have available to you. It's already on the ARPD site, but there's a page like this for each of the organizing ideas from K to 6. And what it does is it lists sort of the key concepts or key ideas related to each of the organizing ideas at each grade. In this example, we've got Earth systems. And we see, for example, that environment, the yellowed items here, which may be hard for you to read, is something that continues from grade to grade. And it's actually within each grade more than what it appears here, just because it's referenced that's an understanding. It's not specifically referenced, but it's an understanding that continues on. Same with the idea of change. The idea of change grows and grows by the time we get from grade 1 all the way to grade 6. We talk about change in general and seasonal changes, and we get to fast and slow changes by the time we get to grade 3 and grade 4, and emphasizing or focusing on climate change by the time we get to grade 6. So those concepts are there, they spiral around, and I want to stop for a moment and talk about the skills again. The skills are important because they're what the students do to demonstrate their knowledge and understanding. When we do an assessment or we give them an activity, they're doing something, and our eyes and ears are open, hearing what the students are saying, watching what they're doing. And when we give them something to do, that gives us lots of knowledge about what they know and they understand. The skills and procedures specifically are not really the entire statement. The entire skills and procedure statement takes the verb, and the curriculum says, let's use this verb to demonstrate what they know or understand. You'll see there's that knowing and understand part. So to have students become familiar with the different verbs and practice using them and getting feedback along the way is really important if that's what they're going to do to demonstrate their learning. And we'll give you some examples shortly here. Now, the chart that I have here, you'll notice is from K to 3. The one for 4 to 6 is not quite completed, but I kept this one up here because the grade 4 to 6 one is going to be so familiar. You'll see that a lot of the verbs are repeated along the way, and that makes a lot of sense because they're really a lot of thinking skills and doing verbs that not only apply at the end of the day to primary and older grades, but it also applies subject to subject. You'll see these same verbs probably show up in your other curricula, and you'll certainly see the same verbs show up in all the different organizing ideas. So to have students familiar with them and to get feedback on them and to take a moment to teach them at some point is really going to be helpful along the way. In this particular example, I have what we've got here are the learner outcome verbs. These are just the verbs. You'll see they're colored off that appear in the learner outcome. So down below here, I do have the learner outcome for grade 5 Earth Systems, and you'll see the 2 verbs in there are already included on the grade 4 to grade 3, K to 3 curriculum. The word analyze, or the verb analyze, and relate, which really, in a sense, connect it. So we're looking at students analyze climate and relate it to weather conditions or connected to. This other slide again shows all the other most frequently used verbs. In this particular case, we're looking at K to 3. So what we've done is taken every skills and procedures statement from K to 3 and all the organizing ideas and did a frequency run. And these are the most frequently used verbs here. That's why we're still not finished the grade 4 to 6 one. There's a lot of statements to work through and to pull the verbs out, but it's going to be a very similar list of verbs. And you can see how easy it is to integrate any of those verbs. And the reason I'm pointing this out is because when we see a skills procedure statement, such as the one in the yellow here, this is the one pulled out of the curriculum guide, explain how climate can affect human and other animal activity. Well, we know that discussion is a really important skill in having students demonstrate what they know, and knowing how to discuss properly and knowing what some of the protocols are with the discussion is a really profound way to really listen closely and hear what students have to say. So perhaps we could use maybe just instead of just explaining it, which is fairly much an individual thing, maybe let's have a discussion. And there are countless ways to organize discussions, from think, pair, share, or a whole bunch of gallery walks. There's multiple ways to organize a discussion. Or how about if students represent how climate can affect human and other other animal activity? The reason I'm suggesting this is because those skills, we can use them anywhere and everywhere. They transfer from grade to grade, from organizing idea to organizing idea. And the more iterations, for example, if you can see here, I've got 3 iterations, or 3 times in 3 different ways, students are are demonstrating what they know about how climate can affect human activities. The more iterations and trials that students have to do that, what we'll see is that that's how we deepen their learning. So we may be getting at a surface level here, but the more iterations and context they see that in, the deeper their understanding gets, which is going to bring us closer to those phases of learning. I just want to finish off with the understanding. Just a quick review, just to remind ourselves that the understanding is really made up of those individual concepts, and they're just put together in a logical and meaningful way in a statement. So we take those little chunks, such as agricultural practices that we've learned in the knowledge section of this organizing idea, and we've talked about weather events in this organizing idea and climate. Students know what these individual things are, but when we put them together, we can get two different understandings. One might be climate and weather events influence agricultural practices. And to make sure that makes logical and meaningful sense, we ask ourselves, are there examples where we can think of climate and weather events influencing agricultural practices? Would irrigation as an agricultural practice take place in an area that gets lots of rainfall? No, for example. Another understanding, but using these same concepts, so the concepts haven't changed, but when we put them together in a different order, the understanding or the totality or the wholeness or the total of it is different. For example, agricultural practices are researched and tested to adapt to climate and weather events. A totally different understanding, although same concepts. And you can see then that the understanding that the curriculum is focusing on for grade 5, that should say grade 5, not grade 3, that climate and weather events influence agricultural practices. And then in the knowledge piece, we can see examples of agricultural practices. So at the end of the day, the understandings transfer. In other words, we can use them from organizing idea to organizing idea, or grade to grade, or subject to subject. Same with the understandings and the skills and procedures. Concepts, again, transferred. We can see that there are some concepts down below here. For example, if we were to take some of those, such as just climate and weather, we could probably say that we could look through the ends of climate and say, well, this place has a climate that has a cold winter. Perhaps a warm summer for the trees to get so big. This climate, this is a context that somewhere has a warm summer for sure. We don't know if it's tropical or all year. We don't know that, but we do know that it gets warm enough for these things to turn green and to flourish. We can look at it through the eyes of weather, such as raining and snowing and the conditions of that, and so on. So concepts transfer, we can have kids look at those concepts in two different concepts, and they can talk about it and demonstrate what they know. Here's an understanding from grade 5. Climate and weather events influence agricultural practices. We could ask students to elaborate on this. How does this picture demonstrate that? And I've included the grade 4 understanding here again as just another example of how we can take one context and look at it through the lens of one understanding and see it differently. Or we could take a look at through the grade 4 lens and say, well, how do the different systems, the hydrosphere, the biosphere, the lithosphere, and so on, interact in this picture? We can see the soil, the lithosphere. We can see something with the hydrosphere here, the biosphere, the person and the plants doing something together. What is the interaction that's happening there? So all those things transfer. And so this is where if you've seen our videos before, we covered this graphic talking about, in order to get to the transfer, which is this last stage, and which is really where the assessment phase happens. We know we're going to assess kids. We're going to give them a new situation that they've never seen before to apply the skills and the understandings and the concepts they learned to that situation. For example, just like we did with those pictures. So if you see, so what we have to begin, we do this surface learning. We take skills and concepts and really teach them individually. What do they mean? When we get to the deep learning, we put those together in those understandings, and we start taking a closer look and different experiences and learning that understanding, applying that understanding to different things and exploring that understanding in different situations. And then we give them an opportunity to transfer that. We've covered this in the old decks or the older presentations, and especially the first one of this particular series, but I've added 2 items onto this one. One is the arrows that spiral in and out. all I'm getting at there is that sometimes it's not a linear progression going from surface to deep. Sometimes it's a step forward, move back at each of the stages to make sure the students are with us. And we do that by that formative assessment piece, and that's going to help guide us whether we keep moving forward or rotating back. And I also added these 2 arrows in that are new to these things. I've added understandings with this arrows because understandings, this is where they begin. This is where is at the deep learning. As soon as students start putting together 1 or 2 concepts together and they can say how they're related in some way, we're getting into deep understanding because they can't put those concepts together unless they understand those individual concepts. And then we develop that particular understanding in different contexts, which are the different colors, of course, and transfer. And finally, that last arrow, which is new, just means that we can know skills and concepts at a surface level. We know what, for example, compare and contrast is, but we don't know exactly how to do it. When we know it deeply enough, we can transfer it to many situations independently. Same with a concept. At a surface level, it just might be the memorization, and any examples given might be ones that were introduced at that surface level. We know that students get a deeper and deeper understanding of that concept when they can recognize that concept in new context. Just as we did with those different pictures, if they can describe climate in a picture of different contexts, we know that they've got a deep understanding of that particular context. So how do we get there? This is how we get there. Now what we're going to do is show some examples of how we can get there in the planning. And that planning really, the way we're going to pack the rest of this is to say, let's start with the end in mind. Let's begin with a summative assessment. How are we going to assess the students at the end of the day? And that's going to really help us decide what the kids need to learn, both at the surface level, what do they need to deepen so that they're ready to do that assessment and be successful at it. So the ends that I'm talking about really is the learner outcome as well in the understandings. How do we assess for this? What can we give so that students can demonstrate that they understand that the study of climate helps identify patterns and helps make predictions? So if I'm going to use that as my starting point, what I've done for you is giving you an example. I've created an assessment to go for this. Before I go to that one, I just want to maybe review the understanding so you get a better idea of what's in this organizing idea if you haven't looked at it closely yet. If you remember the concept map that I gave for grade 5, you could probably see these concepts show up very clearly in these understandings. So we're also looking at weather conditions are able to be measured accurately using a variety of tools and methods. So we're talking about things like thermometers and so on, and predicting weather. The third understanding is that climate affects human and animal activity. The fourth understanding, climate and weather events influence agricultural practices. So you can see how 4 is closely connected to 3 because agricultural practice is a human activity. So it's sort of a sub-understanding of that larger one. And finally, we get a First Nations or Indigenous, perspective. We're talking about intergeneral observations, being able to help communities recognize patterns and cycles related to weather and seasons. I'm not going to go through all these with you in terms of an assessment, but I'm going to focus on that first one. So if I have an assessment, what I need to do to back up and get this done, So I'm going to work on this understanding that the study of climates across regions, I'm going to focus on the word helps to identify or helps to make predictions. I'm going to focus on that part of the understanding. And so the question is, well, what are they going to do? How am I going to assess them? I am going to use the verb that comes out of the learner outcome. So it's good. Here's what they're going to do. Students are going to analyze different climographs. And by analyzing them, they're going to be able to predict which location on a map matches to the climograph. And they're going to use 2 things. Then these are 2 characteristics of, or 2 factors that affect climate: geographical location and proximity to a water body. It's a mouthful. I'll just give you a quick view of that assessment. What it entails is this. Here we go. So I've got 7 locations, and you'll notice something when you see them on a map. They're sort of parallel for a specific reason. And what students do is they need to match up a climate graph to that location. So here are the 7 locations. You'll notice that we've got some that are more northern, okay, which is that whole geographic location factor. So I'm just going to keep my eyes open, use that factor. And then proximity to a large body of water is the other factor. So we've got some locations that are more northern and southern, so that's going to affect their temperature. But also the proximity to this water body is going to affect things the further away you move from that water body. And as we know, the ocean has a moderating effect. It keeps things a bit cooler in the summer and certainly warmer in the winter, the closer you are to that large water body. And so we would expect that as we move further away, the winter should be colder because there's less moderating effect for us out here in the prairies versus along the coast here. And certainly when you're close to a large water body, that proximity is going to increase the amount of precipitation you get. So those 2 things should be evident in the climograph, where students can look at them and make their prediction based on those 2 things. And so what happens is students will be given different climographs, one for each location, and they can total up the amount of precipitation. They can compare how warm and cold it gets in the winter and summer to make some predictions as to which climate graph these belong to. And then their final question is going to be at the end of the day. I'm just going to flow back to that first picture. I guess I'm missing something. And then what they do at the end of the day is say, okay, how does my understanding of climate help me predict where these places are? And so that's how we connect it to the understanding. You notice that anything that has a link now, that's linked directly to something we've created at ARPDC. There's this use template button up here. What you do is just, if you like what you see here, by previewing it, you click use template and it'll download a copy for you. And I see Chris is with us. Welcome, Chris. I don't know when you popped in.
Just a few minutes ago. You're doing great. Carry on.
Okay. So you can see that assessment's fairly huge. And the question was, well, what do they need to know to be able to do that? Well, what they need to know is all we introduce at the surface level and we deepen through different experiences. So having students work with the climate graph, as you know, is not going to be the first time they've ever done that. If you do the surface learning and teach what it is and how to practice it and give many practices with it, and even practices such as exactly with this, but using different climate graphs, in other words, different contexts, students should become familiar with a task like this and be able to make those predictions. But here are a whole lot of things that students need to know. They all don't have to be taught in science. Many of them were taught in such as the graph information, a line graph and a bar graph, and the notion of axis. That was all done in grade 2 math. So students should be able to bring that forward. So those are things they need to know. And they also have to be familiar with that whole task of analyzing, what does that mean, and how to read a climate graph, even though they can read a line graph and a bar graph. A climate graph combines 2 together, so it takes a little bit of a different read, and there's an activity there we'll cover later on that helps students to unpack that. So again, coming back to our graphic of surface deep and transfer, all those things that I just asked, what will students be able to have to do and have to know to be successful on that summative assessment that they have to know these things. And these are things that I would make sure happen on the surface level. So if they are new to the students, I do some pre-assessment to find out where they're at with that. And if I have to teach to those, I will at the surface level. But there are also sometimes some other things that come into play. For example, being able to read a bar graph and a line graph. That was some prior learning, and there are some science concepts and understandings that also come into play that may be part of their prior learning. So you'll want to do some pre-assessment at this surface level stage as well to know what is it that I'm going to have kids know and do that they should be coming into this grade with. And this is where Chris is going to take over and go through a whole lot of wonderful activities that she's got here. Starts from way back several grades, because as you've seen our concept map grow from grade 2 and up, there are a lot of things in there that are connected and come into play here. So Chris, I'll let you take over. And if you do want to take over the slides at this point as well.
Okay, I can do that.
Might be easier for you.
So Ted was quite right. There is a fair bit of pre-assessment that needs to happen here because there is a lot of terminology in this dot or in this particular organizing idea, which I would say comes in with the assumption that they know a lot of things. And they may not right now because they may not have had all of the benefits of the new curriculum already coming before them. So there will be things that we need to really look at. And in this prior learning section, what you have is just some of the slides. By no means is it all of a grade, but just some of the key combinations of wording, sometimes the concepts that were covered that would be really beneficial for them to make sure that they have a good understanding of before you kind of launch into this. Although we're focused very much on weather and climate, the interconnections, the parts of the spheres that they learn in grade 4, like all of that stuff really does fit into here. So again, doing some careful analysis and questioning of the students to find out where they're at. So environment is one for sure. And any one of these are slides from previous years that you could go into any of the grades. You have access to all of them anyway. So you could go in and grab any of the slides that you would need in their entirety if you want, so that you can go through it. But again, what is an environment? And if they don't even know what that is, Ted has an excellent concept attainment that's attached to this, where they can go through and go through some yes/no conversations about this is an example of it, this is not an example of it, and then what are we going to call an environment? How are we going to describe it? What is it we really think they are? But they need to know that. I mean, if you're going to talk about climate and temperature and weather, then I need to know something about the environment that I'm talking about, because as I just take the one that I came in on when we're looking at Ted's map of Canada there in the provinces, and those that are landlocked and those that are sitting by the water, those environments are very different. And so they're going to have different emphasis and different impacts as well from their location. Oh, okay. I guess I launched into that one automatically. So here is do you want to go into this one, Ted? Do you want to talk about it? I'm in it, so I might as well go there.
Might as well go there. Environment is really made up. When you look at the definition, it's made up of two things. You can keep on going, Chris. It's a space. So that's one idea. That includes a variety of objects. So the first part just talks about spaces. What are spaces? We have different spaces in the school. I think that's what we're really developing the whole idea of that. It's just a space. The outside is a space, the inside is a space, and so on. So that's the first thing we help students understand. And then once we kind of have a grasp of that, then we go through the concept attainment lesson itself. And concept attainment lesson, in its really simplest form, you give students examples and non-examples, and they use those examples and non-examples to generate the criteria for what that concept is. So you can see what I mean when we look at these here. Now, these are presented in a certain way. These are just instructions for the teachers because it's very much based on just photos. So at the end of the day, I have a bunch of photos. They're numbered, as you see in that graphic there, and they're given a title there. So as I'm presenting them, I would actually have these pictures printed out, and I would put Group A as an example of an environment, Group B, and so on. And then after looking at those examples, we ask them, what do all the things have in common? And you'll see that the two environments that I'm developing is a gym and a classroom. So you can go through those pictures, Chris. So you can see that as I talk to the kids, I'll group one in as a classroom picture. I won't have the title of classroom. I'll just have this is a yes, and this belongs here. And I'll group them into two groups. And then they develop that understanding, well, that those are objects in either a classroom or objects you'll find in a gym. And then the rest of the activity goes into exploring a little bit more. Well, what are the objects in our environment? And what is an environment? An environment is a space that has objects in that space, essentially. So environments are brought up, first of all, at the kindergarten level. And this is one just very graphic for kindergartners who still can't read. But that's how concept attainment lessons work, is giving those examples, non-examples, and getting students not only to know the definition, but also be able to recognize instances in it.
So one of the other things that we shared with the teachers in the previous grade was just a graphic, because we had been already talking about man-made, human-made. Those were all components of other presentations, as was natural. So what's natural in the environment? What is man-made in the environment? I have to learn that nothing is man-made that didn't come from a natural product to begin with. So this was just a nice little graphic that they could use or refer to, or maybe this is one that you can use as a quick follow through of what do they know about natural and man-made? Are they familiar with the terminology alone? Moving more into getting into the systems, talking about Earth as a system, almost like a miniature spaceship. What would it, if I took off in a spaceship right now, what would I need to take with me? What would I need to have to survive? And think of that in terms of Earth. If Earth was a spaceship, what are we doing? What do we have around us that keeps us going? What keeps us alive? What are the key elements and components of it? So we explore the air, the water, the land, the life. We talked very much about landforms because their focus was on Alberta first. Let's just talk in something that I can relate to. So more so talking about what we see in Alberta, what are the different variations of landforms, and then getting into some really sort of, if you want to call them hotspots or touristy places or things that we have that are highlighted in our province already because of maybe the landform, because of some of the history that goes along with it. And those are important for the students too, because again, it's making that connection, not just sort of always showing me a picture. Maybe I've been to Mount Edith Cavell. Maybe I've been to Okotoks. I've been to the Prairie. Maybe I've been to a mountain. So, and if I haven't, maybe those are the pieces that I can unpack and learn a little bit more about, not the ones that I've already done. Maybe I'm farming already. So the prairies to me is a common everyday site. I already get that. We also unpack a little bit about UNESCO. Those are referenced in the curriculum about the UNESCO sites in the world. So children learn what's meant by a UNESCO site. And wow, Alberta's got some UNESCO sites. What are they and why are they? Why are they so special? What about them? We also look at sort of what are the landforms that are characteristics to describe a landform. So I can talk about them in size. I can talk about the terrain that's around them. I can talk about the slopes of things, slope of the hill, slope of the rock, if it's a mountain. And why are they different? Why can you go, let's say, to Jasper and look to your left and see a mountain peak that's straight up and it's jagged and it's got all kinds of little peaks on it. Then you look to the other side and it looks like somebody just took a rock and kind of sheared it off and it's really smooth and it seems like it's leaning more than it's rising up. Why is that happening, right? So having that conversation with students. Water, a huge component, certainly of creating landforms, a certain huge component of Earth systems when we talk about that. And they've already talked about the water cycle. So that's parcel of what they've already covered. But what is it about water? Why is water such a powerful tool? Why is it that we need water? Obviously, basic needs. We've talked about basic needs already. But beyond that, like what does water offer us? We have two different kinds of water on Earth, right? We have salt water and fresh water. How are they different? Why are they different? So again, for landforms, we just started off in those particular lessons with something as simple as this graphic. And the reason I use this one here in the review is because if I just want to do that, if I just want to do a quick touch point and see what I know in pre-assessment, this would be a great one because it just goes over some of those basic understandings of landforms. What's the difference between a canyon and a hill? What's the difference, or canyon and a valley? What's the difference between a mountain and a hill? So just again, if children have never been there, that's not obvious for a child. Talking about different kinds of water surfaces on Earth that we were talking about versus what are we seeing for water generation in Alberta? How many students know what a glacier is? How many students could explain to you why do we say that the glacier has a foot or a mouth, or that the glacier moves? Why is that true? So how does that landform get as a result of this movement of the glacier? So there's been a lot of work done already that they have. We talk about the different components. There's the wetlands. There's another one that we talked about yesterday in understanding. As that one becomes more important from an Indigenous perspective. So we highlight one of the locations in Alberta where the elders did a lot of work and they shared with us a lot of the importances of the water, about the meaning behind it, about why is it, and something that I would offer protocol to. And then we move into sort of those landforms. How did some of those happen? How did things change? Is Earth always look the way Earth did? No, it didn't. And so you've got a couple of really kind of cool videos that have been provided to you that are like time-lapse photography. What did it look like 200 million years ago to today? So we know that continents have moved. We know that they didn't look the same. And then you might even throw out the question, what do you think it might look like in 200 million years from now? We're not going to be there, obviously, but maybe they're seeing something that grabs and riveted. There's no right answer to this, for sure not. But we can also ask why, if there's such big changes, you saw that entire continent moved. How come we didn't notice that? How come we don't feel that? How come we don't feel that movement of the earth and those? So we have that conversation too, which is also going to come up in space. A little bit more of a in-house and closer to time. We have a time-lapse photography that happens for glaciers from 1985 to 2020. And why do we want to show them that? Because we talk about human impact. And has human impact actually changed that? We had this photograph of all these glaciers in 1985, and in the same location, I don't see that anymore. Why are they disappearing? What is it? So we talk about global warming. That comes up again in another grade, but nonetheless, we can talk about what are we doing? What are we doing to our spheres that are maybe damaging them and causing our glaciers to disappear? What would happen if the glaciers weren't there? That's another great question to ask students. If they've never seen a glacier, a common one in Alberta is the Athabasca Glacier, because you drive sort of right past it on the highway and you can stop. But even in itself, if I think about when I first saw it as a child, it was right up to the highway. In fact, the part of the highway even went through a section of it. But now it's kilometers back from the highway. Very, very different looking. And is that a good thing or a bad thing? And what impact does that have on us? What potential impact does it have in the future? Those are things that we ask students to consider and look at. We also ask them for, how does our past come back and see us today? So how did fossil fuels, for example, get created? What do the dinosaurs have to tell us about what happened in previous times? What is excavating? How does that tell us about the history of our soil and our land? What do we do when we're a paleontologist and somebody who's looking at ecology as well? How do those two fit together? And what information do we get from that? So these are all videos or slides that have already been used. This is a resource that we suggested might be helpful as well. Digging up dinosaurs, because it gets into what does it tell us about Earth's changes over time. There's also one that deals with weathering. We know that it's not just time, it also weather can affect our landscape. And if you just make it really short-term real, think of a snowstorm. You have tons of snow that comes down in a snowstorm, and you get these 6 and 8 foot drifts that are sitting outside, and people have got to try and dig. That's a short, sudden change. But it's a change, and that's the kind of thing that we expect them to consider as well. As what is those changes? What happens to soil when weather is extreme, and over time, what happens when it? So this is a slide deck with information that goes along with it. Again, we would not expect all of these ever to be brought forward. You need to go through them and decide where the student's at and what you want to use. We talk about conservation. Here. And then we finished yesterday with talking about Earth's 4 spheres. So again, I did not grab all of those because we put them sort of in a Jeopardy format. So if you want that, you need to go back and have a look at it. But one of the opening videos that we had within that set was this one called Earth's Spheres, or the 4 major spheres. So if you just wanted to review them sort of quickly with the students, this would be a good starting point. And you could even ask them, can you name them? If they are not familiar with them, most of them will know most of them already. But nonetheless, this is a great review and a good starting. And then we have some sources that they might consider when we're talking about that. So again, Life on Science, Connecting the Spheres, Science of Learning Hub is a great one because it covers every Earth system. So any one of these would be sources that you could use if you needed to go back. And here's the one that I refer to that when we talk about water, when we talk about land, we talk about the importance and the understandings of land connection in the Indigenous lens, from the Indigenous lens. Sacred Relationships is a site that was filmed exclusively on Lake Wabamun. And all of the entire series that is there, videos and lessons, were targeted at the area and is stepped through. And as you step through the wetlands and you learn about the marsh and you learn about the water and you learn about the brown water and why is brown water so good, we're learning about how that is seen and why is that reverent for Indigenous culture. So the elders are talking in those conversations. They will be talking with the students and giving them information. So again, if you don't have the option to have an elder come to your class, this is another way that we can kind of connect them in the same way and have the elders share the stories that are there. It is a fascinating site. If you've never been there, you could teach your entire wetlands unit in the old curriculum from here, but you're doing it then from an Indigenous lens. And it's fascinating to see some of the information that they have. So I encourage you that even if you're not going to use it with the students, if you've never been there as the teacher or the adult, it's a great information source for you as well. Okay, so let's talk about some different ways that we can talk about surface level activities. I'll turn it over to Ted for a second.
And we are going to move into just sort of some of those surface level activity examples where we introduce students to some of those skills or those basic key ideas that are going to be needed in the understanding and certainly in the assessment piece later on. There are multiple ways to teach things at a surface level. Those are some listed there. With the environment, I showed you a basic concept attainment strategy. Many of the examples that you'll see listed in the next slide are that. But many of you are familiar with the Freyer model and those other things and case studies and so on. So there's probably a lot of that instructional approaches you already have that can be used certainly at the surface level. Now I've divided things up into two groups here. You'll see there's two slides of surface activities because I realized we've got essentially two things here. One are some of those broad concepts and skills that are not necessarily specific to this learning or this organizing idea. For example, on that first slide that I showed how the progressions from grade 2 Earth systems moves all the way up really essentially to grade 6, that one of the common concepts there was systems. So what is a system and understanding that so kids can start making those links together. And we're talking about the atmosphere, the biosphere, and hydrosphere. We're talking about a system. And then they can apply that same understanding of a system of components working together to the skeletal muscular, to the biologic systems and the ecosystems and so on. Relationships is a really important notion that runs through all the science curriculum. You'll often see the word how is this connected to that? You'll often see the verb relate this to that. Relationships exist in many ways, different forms. They could be relationships of dependence. They could be relationships of cause and effects. They could be relationships of interconnection or interaction. So there's some things there. Many of them are concept attainment lessons. Many of them are graphic, intended to be for primary grades and non-readers. But I think if you were to look at them and were interested in developing those ideas, it gives even you a sense of what we mean by those things. And concept maps are a really valuable way of having kids demonstrate that understanding between concepts. And as soon as they can start demonstrating they understand how concepts connected, we know we're in that deep learning phase. So there's an introduction to using concept maps as well. Representing is another one that permeates a lot of the things. We get kids to represent their learning, another deep level verb that can help them demonstrate the understanding. Human activity shows up so many times throughout the curriculum that there's an introductory lesson there to, well, what is human activity? What does that mean? And it gives a starting point if your students might not be totally familiar with what we mean by human activity. Comparing and contrast is one of those skills that go from between organizing idea and grade to grade. And some associated concepts for that is criteria, because you need criteria if you're going to compare and contrast. You can use criteria such as properties of size, shape, color, and so on. You need something to compare and contrast. And of course, you need to understand the concepts of similarity and difference. The link isn't there. I see, but it's not there. And I'm going to mention one more thing. Investigation is another one of those skills that permeates everything. Investigation shows up in grade, at least the steps of the investigation process shows up in grade 2. The expectation is that students understand and use these steps of asking questions, observing, analyze, predicting, making conclusions, and so on. And so even at grade 5, we get to go back to that grade 2 scientific methods organizing idea to see that. If you just don't have to click on it now, but where it says investigation from grade 2 scientific methods, that gives a more broader explanation of the steps and links to some practice activities to get students familiar with that. And finally, one, it's not linked there, evaluate, but that's another one that students can do. And it's because I have an activity showing up later that uses evaluate, but the introductory activity hasn't been completed yet. So the next slide then has, again, at the surface level, there's lots of things that kids need to know as well. As we mentioned, for that one assessment, we're looking at that reading climate graphs. So there's a link there for students if you want to learn how to read climate graphs. And then the other key things through here at the surface level that Chris is going to show you are what are some things about climate and weather at the surface level kids need to know. What are the surface, what are tools and how do they work? And what are things called agricultural practices? Those are some of those big surface level things that kids need to know. Once they know those things, they can apply those at the deep level. Chris?
All right. So kind of keeping along with the Jeopardy, not question format, but really so much of what we need to start at the surface level in grade 5 is unpacking the misnomer and misconception that students have is that weather and climate are the same thing, right? They need to discern that both of those are not. And I need to make sure I take the time to really unpack that with the students. So this is a way that we might frame some of this. I'm not saying this is your unit. I'm just saying these are the things that we have in that order. If you wish to use them in that order, that's fine. But that was not the intent of it. So when I look at the very first part, when I said the misconception, this is an activity of 16 cards. And in this, what they're trying to do is really get students to understand what they believe to be true about weather. Because again, if I think that weather and climate are one and the same, I'm not going to really be able to get through this very easily because I'm not going to be finding the connections in the way I want them to. So this activity is done with 16 cards in a process called 1, 2, 4, which means that what happens, I get some cards, I look at the card, I make some decisions about what the question is asking me, what answer would I have. I'm then going to find a partner, and the partner and I are going to share what we found. And we may not have the same pictures, but we're going to look at each one, we'll share what we have, and we're going to agree what we're going to say if we had to go another level, which we are. So my partner and I are going to then find another set of 2 people, and we're going to do the same thing. So it's really starting to consolidate the thinking, but also it opens it up to, if I missed it completely, I believe that climate and weather are the same, but the other people I'm meeting have got a clear understanding about what they believe to be true, then we have that conversation and that dialogue. So the cards are in here, the activity is in here as well. So it's a matter of you going and just finding into, I'm not going to go through the activity itself. And then we need to do some teaching, that surface level teaching. There is a video here. You'll notice that not everything has been filled in, and that's never my intent. I'm not a define, put up on the board kind of person. That's just me. I prefer talking about it, prefer showing you, and then I would prefer that you write it in your own language to see if you got it and that you understand it. That's my preference. But here what we're really doing is we're looking at a surface level, starting to unpack what is weather versus what is climate. So that we're starting to see that they are not the same. So we start unpacking them. We look at some of the things that are the same: temperature, wind, humidity, precipitation, clouds, and the amount of sunlight when I'm talking about weather side. When I go over to the climate side, I'm talking about the geographical location making a difference. If I live right on the edge of the ocean, that's going to be very different than I live in Alberta, because we don't even have that kind of body of water, and we're not housed and surrounded by it. So when you're landlocked, that looks very different. So again, we might also talk about the climate is also dependent on the geographical location, as I was just talking about, the terrain. When I lived in Hinton, I can tell you that we would sometimes wake up at 2 o'clock in the morning, and then when we went to bed, it was minus 22. It was cold. And then when you wake up at 2 o'clock in the morning, you'd hear water running outside, because I had a Chinook that came through down the side of the mountain. You're right there in the path of the Chinook, and we could be at 12 degrees, and the snow is just melting like crazy. And within 24 hours, you're back to freezing, so you've got solid ice. So again, it's the terrain and the location that I am geographically is going to make a huge difference in what I'm experiencing. The altitude that you're at, proximity to waters we were talking about. So again, this is one of those starting points. These are critical surface level foundational understandings that the kids need to know. So before I get into actually doing comparisons of anything, I need to understand what these words mean. And this short little video at the bottom will give you another source of information. Once I kind of know that, I might want to say, well, I'd like to measure temperature. And how do we measure some of those things that we've been talking and learning about? So I need to be able to, say, measure the temperature outside, the wind speed outside. I need to know what's the humidity level. And again, we could even just take a snapshot. We could take a quick screen recording of any kind of weather report in any part of the year where it talks about the humidity today is, the sun is, where we get all that framed every morning, you know, make sure you've got your sunscreen on because our index today is at. Those are all ways that we are reporting the weather that we're about to encounter on a given day. What's the wind speed? Is that at 50 kilometers an hour? That's what it was yesterday. What was it today? So those types of things. So again, what are some of the tools that I would use to measure all of those things that I'm talking about? Another really great one, even during COVID, when we were doing another version of this, we had online, we simply invited the weatherman from Global to come in. And he just came online and did some talking about how he prepares a weather report. What does he go look for? What does he need to know in order for him to give us all of that information? What tools does he use? Where does he get his information? What kinds of things can we measure at home if I wanted to do it by myself? Thermometers are an easy one because most children have seen a thermometer. Most of them know what it measures, but not all children. So sometimes you still need to take the time to go through and show them how to measure with a thermometer. Where is it on both sides that it's equal? We have Celsius and we have Fahrenheit on there. And although we're not always doing Fahrenheit, it's there. They see it. They just maybe don't acknowledge it, but what about it? In grade 3, we are doing 2. Wow, that was just like an entire scenario happening there with all of them taking off. When we are looking at measurement of temperature, we have places where the Celsius and Fahrenheit meet. Where are they? And I don't have to know any formulas. I just need to know how to read them and compare the two. So lots of surface level stuff happening there first. Before we even think about doing a deeper understanding, the relationships between them, I need to be really clear on what is the language that goes along with weather and what is the language that goes along with climate. So then I can take any location, maybe even some of those ones that we showed you from previous grades, and I can do some analysis of that. I can do some understandings of how they're the same and how they're different. Okay, one of them too. Is this the one that you had already used, Ted? Is this the one that you had referenced? No, okay, good. So with this one, we're just talking about weather patterns. And so in this case, if I was, and I could actually just piggyback off of the first one that Ted showed you, but have the students watch a weather report. Most of them at that age, that's not my interest. I'm looking for something else, right? Have them sit down and have them give them a blank Alberta map and what kind of fronts are coming through. Depends on what kind of the year it is. What's influencing the weather? Where is it coming from? Are we getting something from the north? Are we getting something from the westerlies that are blowing in? So what is affecting our weather that's coming up in the next 24 hours? And just again, so that they start to think about it. So be a meteorologist and predict the weather for tomorrow. Now that I watched it or heard it, what do you think is going to happen? And now that I learned a little bit about it, take a guess. What do you think might happen tomorrow? But then if you watch the weather and find that there's a front moving in that you didn't know about, then obviously I might change it. But this is an opportunity. This is an easy real world application that they can get into right away. And also start to think about, hey, the weather report tells me a lot of things. So I need to pay attention to that a little bit more. Okay. And I guess the second piece was, we talked about this already, but what are some of the effects of where I live? So the weather that I had in Hinton wouldn't necessarily be the same weather that I would experience where I'm coming to from now in Camrose. 2 different scenarios. You would have different kinds of storms that would come in. We would get different kinds of snowfalls than you would here. Not saying that we don't get them in central Alberta, but of course you do. But there's different influences again of the air that comes over the mountains, and the moisture that comes over the mountains affects it. So again, the students need to find, maybe describe where they live first, and then find a location that they haven't visited before and see what they can predict there. When we talk about how accurate is a homemade weather tool, I don't know, but first I have to find the accuracy. I better make one of those. And there are lots of different ways that they could make the following. This could be a great class project where you break them up into groups and each group is making a different one. Their responsibility would also to be explain what is the purpose of that? What are they measuring? What are they getting from there? So that would be another piece that we could do. And there's lots of places and websites that we can get that information from. Okay. Do you want to talk about your concept map or you want me to keep going?
Sure, it's just another example of showing that for students to demonstrate their understanding. If they could put those ideas together in a meaningful concept map and explain it, that shows that connection between concepts and identifies a deep learning that can happen, or identifies a deep knowledge of those things. They can't connect them if they don't know what they are. Same with this. This is just a different understanding, though. We're talking about weather events and their influence on agricultural practices. So what do they understand and how they're about the agricultural practices and how they are connected to weather.
And that too opens another area of study that comes into this whole organizing idea, and that is, what are we doing in agricultural practices to conserve or to maintain the environment and the land? That's another piece that we want to talk about. Some people will have rows, wind rows that they're going to leave up so that they catch some of the snow, they catch some of the moisture over the winter time. Again, what are the practices? And if I'm in a farming community, that's probably a very easy answer for me. Versus if I'm living in a mountain community, that's not going to be something I'm familiar with. So again, having them really get good at the area that they live in first, but then the importance of transferring that to understanding outside of where I'm at. How do I apply what I've learned now to a completely new location? What am I seeing there that's going to impact the conservation and the preservation, and the way that we are looking at how we are able to maintain, if in this case it was prairie land, if I'm looking for it. Okay, so those are just pieces that we want to have in here, and that's what comes up next. That conversation that we have with students about conservation, agricultural conservation, and there's all different kinds of practices. Some of them could be just planting trees. There are lots of farmers that are cutting down the trees so that they can get more land. And then there's the flip side saying, we're getting way too much wind. It's changing the pattern of our soil. It's stripping us of some of the most nutrient soil because nothing can break the wind. So we're planting trees. We're doing the opposite. So again, what are some common agricultural practices? Crop rotations, limiting the amount of hunting and trapping that's on there. And again, that would be a different conversation to have. What are some harvests that you would have? Do you always plant the same thing every year in the same place? A lot of farmers will say, no, we do a crop rotation because different plants take out different nutrients from the soil. Some of them strip them way more than others do. So we have to rotate them around and get the soil more healthy again, and those types of things. So these are just samples. Obviously, you can go deeper than that, but that gives you a starting point of what we might look at. Another interesting one, and this is an actual, I'll just talk about it and then you can go into it when you get the slide deck. But when you click on this link, this is an actual website that you're going to go to. And we could say, now that we've learned something about where we live, we know a little bit more about Alberta, where would you prefer to live? Is there something about weather or climate that you like in particular that you're not experiencing? So where do you think you could find that? Or would it be better for me to live in Alberta versus Ontario? Would it be better for me to live in Alberta versus Saskatchewan, etc.? So in here, this app will allow them to go in and do that. What it will do is it'll allow them to pick where I want to go. And I don't have to stay in Canada either. Maybe I want to check Alberta versus the Dominican Republic, right? How are they the same? How are they different? So when I put these in and you go into the actual program itself, it will give them the graphs. It will give them what kind of weathers we see, what kind of rain patterns do we see. I can make some decisions. And I wouldn't just say, which one do you prefer? And just let them get away with Dominican Republic. Why? What is it? Tell me about the patterns that you've seen. Tell me about the climate that you're that's resonating with you? Tell me about the weather patterns that you're seeing. What is it? And be quite explicit in it. So again, they have that analysis that they can do. Another one is, and this comes from the First Nations kits that were made in 2017. There is a lesson in here. It says Science 10, but it actually fits very well and it's very understandable. It's not up there for high school language. But talking about Indigenous knowledge and cultural weather perspectives, like how do they see this? And when we think about how did the migration patterns of animals influence the information that First Nations people who were living off the land, what does that tell them? Well, it tells them when it got colder and the birds are starting to flock and fly, they know that the weather is changing. They're into a different season. You didn't have to have a calendar on the wall or somebody announcing that this is the first day of fall. We would use the natural setting and be observant of that to make decisions from there. So this link in here is an entire unit of study. But again, you would maybe just go through and have a look at what you want from there. And also in here, what's the benefits or knowing about the 13 moons on the turtle's back? And if you don't know that, we're not going to go through the whole scenario here, but how does the 13 moons on turtle's back tie into weather or climate? In this case, weather. It also, what it really does is it maps out our entire calendar year into 13 months. And we know that our seasons are changed every 3 months. We have a new season, but there's things happening in those seasons that the sun is changing its altitude. Our warmth that we get from the sun changes because of our distance and our rotation and where we're, all those things. How does that fit with what we call on the back of a turtle, the 13 moons? So it's a very interesting opportunity for you to explore that with the students and let them make some connections. So I'll leave that one to you as well. And that kind of got spurred from a book that a teacher was asking me about, saying, I don't understand about this Turtle Island. Why do they call it Turtle Island? And that was what prompted that conversation. So the number of sections that are on the back of a turtle doesn't change and doesn't vary. It might change in size, but it doesn't change in the number that's there. And each one of those has a meaning. Now, it will change for individual cultures. So if I'm looking from different lenses through Cree lens versus Métis lens, I'm going to have very different interpretations of what this is, but the premise behind it is still the same. So again, you would look at what is the most relevant to the students that are in your class. And this also allows all of our Indigenous children to find themselves in this science curriculum as well, not just to see it from one perspective. As I was mentioning, how do those patterns that animals display, how does that inform us about things that are changing? How does that predict that weather is going to change? Well, when we see animals getting ready to hibernate, they're feeding frenzy to get as much food and fat built up as they can. We see animals flying south is usually an indicator for us where we live that it's going to get colder. And so we know that temperatures are going to change. When we see water starting to break up, we see waters on top of ice surfaces, we know that tends to start to warm up. The sun's rays are starting to take that water and melt the ice. And so now I know that I'm getting into a warmer strand. So I'm getting into the spring and moving into summer. So again, it's just those different components. Plant life cycles. A lot of our children believe that you can only in Alberta plant in spring. They believe that that's where we plant. And yet we have plants that you could put into your garden as soon as the frost comes and it gets really cold. That's actually a really good time to go out there and throw your Brussels sprout seeds in and your cabbage seeds in, because they don't care about the snow. They're just going to sit there, but they'll be the first ones up in spring. And they don't care if it gets a little warm and a little cold. They'll be fine with that. There are lots of farmers that plant winter wheat. So right now, as you're driving around where people are tilling under their ground and trying to get everything ready for the fall and for the winter, you see some that have beautiful green fields. So they're planting a type of wheat that's not going to be harmed by the winter and will come up again and grows a little bit faster throughout the year than the other ones do. So again, it's that knowledge of where do they live? What can they learn about where I don't live? Okay, so we have some tasks. We have some tasks in here that could be possible ones that you could use either as another deeper understanding, or could also be one in which we're talking about, oh, that's not the one I'm thinking of. I think that's from a different one. Nope, that isn't. That's right. Yep, it's right. So we're talking again about how climate, in this case, could be the farming, could be the animals, right? If I've never seen an animal who hibernates, if I don't know anything about that, I live in the city. I don't see anything that's running around that you're talking about. How do I investigate that? So this is another opportunity for me to have that. Okay, how climate affects the human activity as well. Okay, let's keep going here and into transfer. Okay, do you want to talk about this one, Ted?
Sure. This is just focusing on one component of that understanding. You see it's highlighted there that students analyze climate and then connect it to weather conditions. And so it's kind of related to some of the maybe surface level activities that you may have done that Chris mentioned about looking at forecasts and taking getting a deep understanding of what they mean, how to read them, how to interpret them. And so, you know, one part of the surface learning that happens in the first cost line that students review or are introduced to what climate zones are. There are the 5 there that are referenced in there. And one way perhaps to assess whether students can analyze climate and connect it to current weather conditions is to give them a forecast to a location. For example, if it's a tropical location, you'll want to look something, forecast that has lots of warm temperatures and the humidity is high, and the 10-day outlook is lots of warm weather or lots high humidity and lots of moisture. They should be able to take that forecast and say, okay, which climate zone does that best represent? So they'll have to, in order to do that, they have to analyze the climate data in the forecast or the weather information in the forecast. And they have to, analyze, I suspect that there would be a write-up there about what tropical climates, dry climates, and so on mean, and then making that connection or relating the two together. So that might be another example of a transfer or somewhat of assessment you may want to do.
And so we have a few resources that might be helpful to you down the road. And again, only there if you need them. These are the ones that directly link to your learner outcome. There are some others from our organizing idea. There are some from previous grades as well, but this is one that kind of is housed for you right now. And some of these, this is the one that we talked about for the Science 10 one, where we talk about Indigenous perspectives on climate. This is the direct link and where we got it from. But you also have some other ones. And I also want to remind you that in any of your organizing ideas, this is not the only one. You can take virtual field trips. If you don't have the budget to leave your classroom, then let's leave our classroom through technology and see what we observe that way. So those are always options that we can have as well. So I'll leave those links with you as well. Here are some things about the spheres again that we have, but also they really fit well into some of the conversations that you might have had with your students already. So this comes from a previous grade, as does this one here. So again, you're going to use these only as needed. The powerful ocean is a great one because it talks about the 2 different kinds of water, but it also in here will talk about how does the proximity to an ocean, or not even a proximity, how does the ocean affect our weather? What kinds of things does the ocean do that causes us to see a super hot summer or a super cold and wet and snowy winter? Those are also part and parcel of the circulation that's coming around through the ocean currents and how they affect our weather. Seems like it's way out there, and yet it's very much a part of what we do. And this is one from yesterday, this 4 spheres, but again, it's a great book. It totally covers the entire course. So it would be one that if you really wanted to use that as even a review before we start launching into something and having that one on hand, that would be another one. Okay, and so that's what you have is a number of different resources, different books that you could use in this grade, but also we're working for grade 4. Keepers of the Faith is really, Keepers of the Earth, sorry, is really one that talks about different activities that the students have. And I like this one because it's environment related. And they're legends, sometimes they're stories. They are Native American, so they're US based and perspective, but it's okay for our students to hear something different. We just need to qualify where that legend is coming from. And again, some fascinating stories that come up through the environment through this book. It's made up of a whole bunch of little ones. Another one would be the book called The Walk. We've shown this in a number of different places, but again, the focus of this is an elder walking with a young man through the bush, through the forest, pointing out the 7 sacred animals that they're talking about at that point, but also connecting it to how does Mother Earth look after us. So kind of comes right back full circle to where we were talking about not only in grade 3, grade 4, but what we're doing in grade 5. Okay, we have a colleague, Ange Deering, who is creating computing science links directly for each of the grades. We don't have that link in here right now, but she has got a slide deck and she has a quick sort of idea, a lesson that you might want to use that takes computing science and ties it directly to grade 5, not just in general, grade 5 Earth systems. So it just, if you're welcome to use it, if you don't want to use it, that's fine too, if you have your own. But remember that we are basically connecting Earth systems and scientific method into each of the organizing ideas through a variety of different approaches and activities. So this would be one that we would have in there. Okay. And then we have another meeting in November where we'll be talking about energy. And that will kind of finish it for our K-3 partners, because they do not cover space, and then we will move forward into space after that with you. And that pretty much is a wrap for our new Earth systems. So thank you very much, everyone, for joining us today. We appreciate that a lot. We know it's been a busy day and it's a beautiful day outside, so we don't blame you if you are outside and just taking in some of the weather, that's for sure. So let me just stop our recording.